Hello everyone, today our lecture CSIR NET-2022-September question paper topic real analysis. So first question I will discuss question ID 370. So this question given for alpha greater equals to 0, define an is equals to 1 plus twice alpha plus n to the power alpha by n to the power alpha plus 1, then limit n tending to infinity an is equals to what of the correct answer. Okay, so this problem I will solve. First we write this question. An is equals to 1 plus 2 to the power alpha plus n to the power alpha by n to the power alpha plus 1. Okay, so here this problem we can write 1 by n to the power alpha, 2 to the power alpha by n to the power alpha plus so on n to the power alpha by n to the power alpha. Okay, this problem we also can write 1 by n to the power alpha plus 2 by n to the power alpha plus so on n by n whole to the power alpha. Okay, this is the sum of, so this is also we can write summation form. So summation of r is equals to 1 to n 1 by n r by n whole to the power alpha. Is it clear to everyone? Now we can write taking limit n tending to infinity an is equals to limit n tending to infinity summation of n equals to 1 to n 1 by n r by n whole to the power alpha, and this is the definite integral definition form. So this is this form we can write 0 to 1 x to the power alpha dx. Okay, so this is simple integration. We can find x to the power alpha plus 1 by alpha plus 1 0 to 1. Now upper limit and lower limit put, we get 1 to the power alpha plus 1 by alpha plus 1 minus 0 to the power alpha plus 1 minus alpha plus 1, that simply 1 by alpha plus 1. So with this is equivalent to option 3. So option 3 is correct. I hope this is clear to everyone. Now I will go to the second question. Question ID is 365. So given problem is which of the given sequence an satisfy the following identity? Limit supremum of an n tending to infinity is equals to minus limit n tends to infinity infimum of an. Is it clear? So what is limit supremum and limit infimum? If given sequence 1 2 3 4 minus 1 minus 2 this, so here maximum value is give limit supremum and give minimum value is limit infimum. Is it clear to everyone? Okay, now if given any singleton set value is, if we set any two singleton value, this is supremum and this is also infimum. Okay, so here first option say that an is equals to 1 by n. So first option here an is equals to 1 by n. So limit of n tending to infinity an is gives limit n tending to infinity 1 by n is equals to 0. Okay, so limit supremum of an is equals to 0 and limit infimum is also is 0. So we can write 0 is equals to minus of 0. So it is also satisfied. So first option is correct. Okay, so second question we can write an is equals to given minus 1 whole to the power n 1 plus 1 by n. So now we can distribute even and odd term. So if n is odd, we can find this is minus form. Okay, so here an is equals to minus 1 plus 1 by odd, that means 2n minus 1 time. If we put n is even type, So this is always odd even function 1 plus 1 by 2n type. Is it clear to everyone? Now taking limit n tending to infinity an. This gives -1 and 1. Okay. So here obviously supremum of limit supremum of an is equals to 1 and limit infimum of an is equals to -1. So obviously we can see that this is, we can write supremum of limit supremum of an is equals to 1, that is minus of limit of infimum of an. So second option is also true. Okay. Third option see that here an is equals to 1 plus -1 whole to the power n by n. Similarly we can distribute this even and odd term. So we get, if n is odd, so n is odd, we find 1 minus 1 by 2n minus 1 type. If n is even, we can find 1 plus 1 by 2n type. If we are taking limit an, we get 1 for all even and odd function. So here single term, that is, this is limit supremum and this is limit infimum. So we can not write limit of supremum of an is equals to minus limit of eta, which is not possible. So third option is discarded. Okay. Fourth option here say that an is an enumerable of the rational number in -1 1. So definitely this is the interval -1 and 1. So here limit supremum is 1 and limit infimum of -1. So definitely we can write limit supremum is equals to minus of limit infimum of an. So it is also correct. So here first, second and fourth option is correct. I hope it is clear to everyone. Now go to the third question. Third question say that question ID is 290. Consider the series summation of n equals to 3 to infinity a to the power n by b to the power n log c to the power n whole to the power c, which of for which value of a, b, c belongs to R does series not convergent, that is divergent. Okay. So first option here, mod a less than 1, bc belongs to R. Okay. So mod a less than R means -1 less than a less than 1, a value satisfy, and bc any real number. So if we consider an is equals to 0. Okay. So here, and b is equals to c equals to 1, we can do. So here we see that this series is summation of n equals to 3 to infinity 0 by n log e to n. See also at 0, summation of 0. So summation of 0 is equals to 0. So that is convergent. Is it clear to everyone? But here say that not convergent. So first option is discarded. Okay. Now we put a is equals to 1. Now we take a equals to 1 and c is any real number. So if we put c equals to 0. Okay. C equals to 0 and we take b greater than 1. So if we take b equals to 2. Okay. So here we can write summation of n equals to 3 to infinity. A is 1. So obviously 1 by b square, and log to the power something 0 is always 1. That is summation of n equals to 3 to infinity 1 by n square. By p series p equals to 2 greater than 1, which is convergent. So obviously this option is also discarded. Is it clear to everyone? Now third option. First option say that a equals to 1 and 1 greater equals to b greater equals to 0 and c less than 0. This type of equation we consider. So here we put a equals to 1. Okay. And greater equals to b, that means we consider b equals to 1 also, and c is equals to less than 0. So if we take c is equals to 0. Okay. So here we obviously see that summation of n equals to c to infinity 1 by n. Here 1 b less equals to 1. So definitely eta. So this is by p test we can find b is equals to 1. So that is divergent. So it is correct option. Okay, next if we take, so third option is correct. If we take a equals to -1, if we take a equals to -1 and b equals to 0 and b equals to if we take b equals to 1 and c equals to b greater equals to 0, so if we take b equals to 0 and c equals to 1, so obviously we can find that summation of -1 whole to the power n by log e base n. So this is alternative series. So given alternative series and limit n, and here an is equals to log e base n, its limit n tending to infinity, an is equals to 0, then by Leibniz test we can say that this is convergent. So obviously we can say that this is convergent, this is also discrete. So here option third is correct. I hope is it clear to everyone. Now go to the next question ID number 289. Okay, so here question say that an is equals to n plus n to the power -1. Which of the following is true for the series? Okay, so here obviously we say that here an is equals to n plus n to the power -1. Okay, so an plus 1 is equals to what value? N plus 1 plus of n plus 1 whole to the power -1. Okay, now we put given condition. So summation of n equals to 1 to infinity -1 whole to the power n plus 1 plus 1 by n plus 1 by n factorial. Is it clear to everyone? Now this problem we can distribute. This is the sum of the value. We get summation of n equals to 1 to infinity -1 whole to the power n plus 1 n by n plus 1 plus summation of n equals to 1 to infinity -1 whole to the power n plus 1 by n factorial plus summation of n equals to 1 to infinity 1 by n factorial n plus 1. We can write this -1 whole to the power n plus 1. Is it clear to everyone? Now this is small mistake, this is n factorial. Okay, so this problem we can write that n equals to 1 to infinity -1 whole to the power n plus 1 by n minus 1 factorial. This problem we can find summation of n equals to 1 to infinity -1 whole to the power n plus 1 by n factorial, and this problem we can write n equals to 1 to infinity -1 whole to the power n plus 1 by n plus 1 factorial. Is it clear to everyone? Now we explain this summation value. We can find, split the sum of the value, and we get, if put 1, so we can find 0 factorial, that's mean 1 minus this 2 means 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, so on. Okay, if I put second value, we get this is 1 by 1 factorial minus 1 by 2 factorial plus 1 by 3 factorial minus 1 by 4 factorial, so on. Okay, and this we can write, if we put n equals to 1, so n equals to 1, that's mean 1 by 2 factorial, 1 by 3 factorial, 1 by minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial, so on. Okay, if also we know that e to the power 1 is equals to 1 plus 1 by 1 factorial, 1 by 2 factorial, so on. Okay, e to the power -1 is equals to 1 minus 1 by 1 factorial, 1 by 2 factorial, 1 by 3 factorial, so on. So here given series this form. Okay, alternative sign. So first option is arranging. Second option, here we see that if we consider -1 common, then this is the form of this type, and also add 1, and here adjust 1 minus 1, and we can find easily e to the power minus 1 form. Okay, so here we see that first option here e to the power minus 1 equivalent to, and second option we can find if we consider minus 1. So here we write here minus 1 minus 1 plus 1 by 2 factorial minus 1 by 3 factorial. This is equivalent to this, and here we extra term is plus minus 1, so obviously add plus 1. Okay, and this problem, this summation we can write e to the power minus 1. So here we see that e to the power minus 1 minus e to the power minus 1 plus e to the power minus 1 plus 1. So we can find e to the power minus 1 plus 1. So which is equivalent to option 4. So it is correct to option 4. It converges to e to the power minus 1 plus 1. I hope it is clear to everyone. So this is the last question, and question ID is 291. Suppose AN and BN bounded sequence, and which option is correct? So here we, if AN and BN bounded sequence, so everyone note this problem. Note this, J limit, that is limit supremum of AN plus BN, we can write is equals to limit of supremum of AN plus limit of supremum of BN. Okay, here minus 1 whole to the power n, that is here if n is odd, that is minus form. So also we can also limit supremum of AN minus BN is less equals to limit of supremum of AN, here give minus sign, so that is plus limit infimum of BN. Okay, so this is the negative sign also given. So obviously limit sub and limit infimum exists, then this is the correct option. So first option is not correct, second option is not correct, here limit infimum and supremum both exist, so third option is correct. Okay, fourth option say that limit supremum n tending to infinity AN plus minus 1 whole to the power n BN may not exist. So this option discard one counter example. If we consider AN is equals to, we can write 1, okay, and BN is equals to 1 by n. Both are bounded sequence. Okay, so AN plus minus 1 whole to the power n BN is equals to 1 plus minus 1 whole to the power n into 1 by n. Is it clear to everyone? So this is even. So this is type of 1 plus 1 by 2n type, or this is given 1 minus 1 by 2n minus 1 type. If limit n tending to infinity AN plus minus 1 whole to the power n BN is equals to 1. So obviously limit of n tending to infinity supremum of AN plus minus 1 whole to the power n of BN is equals to 1. That is finite value. This is exist. So fourth option is also discarded. Okay, so here third option is correct. I hope third option is correct. I hope it is clear to everyone. If any doubt, please comment below. Thank you.